Hello, good morning, everybody.
Good morning.
Um, Thank you all for being here at the Plot Hop. It's really nice to see you all. My name is Gurbir. I am a research scientist here with Farming Smarter, and I'm going to start things off here with a discussion on cover crop management and talking about the potential challenges or benefits that we can get from seeding into standing cover crops. So when it comes to cover crops, there are two main considerations that we have. Number one is how much benefits that they can provide relative to the goals that we have for them. And number two is how do they affect our main crop seeding, growth, yield, the overall performance of main crops. And the way we terminate them, the manner in which we terminate the cover crops, and the timing of their termination can impact both of these considerations. So the normal typical approach is to spray them just before seeding, maybe work them in a little bit with light disking, and that works. That works pretty well. We have very little residue to deal with. There is less residue interference with the seeding equipment. There are less hairpinning issues. But with working the straw in, we do tend to accelerate its decomposition because it gets exposed to soil microorganisms. So does tend to get decomposed pretty quickly. And so we don't have as much left on the surface to protect us from, say, soil erosion. And the problem with tillage is that it tends to disturb the soils. So we tend to lose out on good soil structure. The macropores, which are formed from the root channels of the cover crops, we tend to lose them. They're, they're really important for ensuring good percolation of rainfall, good root penetration, and in general, good soil structure. So we do tend to lose out, at least partially, on on some of the benefits that we get from cover crops when we till them, like good soil structure or the surface covering. And then on the other end of the spectrum, um, we can there's a strategy to plant the main crops into standing cover crops while they're still alive and growing. That provides cover crops a longer time to grow, and they are able to accumulate more above ground biomass and root biomass, and uh, all of the ecological benefits that are linked with the cover crops, whether it is reduction in soil erosion or organic matter inputs into the soils or weed suppression, they're all directly linked to the biomass. So if we are able to get more biomass, we are able to get more benefits, at least the ecological benefits. So the point of this, the main purpose of this project was to see if we can adopt this system under irrigation to maybe tackle some of the main challenges of irrigation, which is soil erosion and weed suppression. So we wanted to see if we can maybe have cover crops reduce soil erosion and weed suppression. We tend to get a lot of dust storms in the fall pretty regularly, and the problem is more acute under irrigated farmlands because of more tillage, and also we tend to grow the root crops like potatoes and sugar beets. They tend to disturb soils more, so the erosion is a bigger problem under irrigation. And if there are living roots that are anchoring the soils, that can reduce the soil blowing off from the fields. It with There is also the problem of wind damage to the seedlings. With the Chinook winds, we tend to get um, 40, 50, 60 kilometer per hour winds days on end. The gusts can reach up to 80 or even 100 kilometers an hour speed. So there's a risk of damage to especially the younger seedlings. Now with the cereal crops, they can survive. they do get damage to their leaves, but they can survive because their growing point is below the surface. But with the canola, with its growing point above the surface, it is more sensitive to the wind damage. So, so with the seed production canola, there is a concern with the wind damage. And if there are cover crops growing interrow, they can protect from those winds. And it's not just the wind damage or wind erosion. Uh, we do tend to get heavy gusts of rainfall um, that are concentrated in short periods of time, and they tend to detach and take a lot of soil out of the fields with the flow. So if there are plants and roots interrupting that flow, that can protect a lot of soil from going from the farms into the ditches. And herbicide resistance is one of the major problems overall in agriculture. So if there are cover crops growing in early spring and in that early establishment period, they can compete with the weeds, and they can reduce weed pressure and maybe in crop herbicide application. And this system is used a lot in organic systems, although with those systems they have to find a way to kill the cover crops by using either roller crimping or another strategy. If we use it in more conventional systems with herbicides, then there is a trade-off of how much herbicide we are using to terminate the cover crops and how much they are able to reduce our potential in crop applications by less weed pressure. So that is something that does need to be considered. And then there are some other advantages, like if the cover crops are growing for a longer period of time, they can reach the flowering stage, and they can attract some pollinator insects, which is good. Some studies have seen that if the cover crops stay in ground longer, that is good for overall soil health and soil microbial biomass. And with the more accumulation of biomass, we do tend to have more organic matter accumulation. So there are benefits to this system, but one of the main challenges is competition between the cover crop and the cash crop, and that's something that we need to take into account and have our management practices tailored to so that we can minimize that kind of competition. And so that's that is one of the main um, points of this study, to to look at the feasibility of this system of where we seed the main crops directly into the cover crops, and to see if we can tweak the management practices so that we can maybe tailor these systems to be successful under our growing conditions. It's a 4-year study. It started last year 2022 in the fall, so this is year one of the study. Um, and it's being conducted at 2 locations every year, Lethbridge and Bow Island this year. So we expect to have around 8 site years of data by the time program ends. And it's a part of a bigger program called Saving Soils, where the main objective is to look at cover crop management under irrigation and to reduce soil erosion. It's being funded by RBC's Tech for Nature program and Western Foundation Soil Health Initiative. So for this project, we looked at 3 main crops: um, dry beans, corn, and canola. For corn and canola, we had fall rye and winter peas seeded in the fall last year around September 20th. And for dry beans, we had only fall rye as the cover crop. We didn't have winter pea in the mix. We had cover crops sown at 2 seeding rates. One was a higher seeding rate, around 300 seeds per meter square for fall rye, and around 100 seeds per meter square for winter peas. And then there was a lower seeding rate, which was half of these rates, 150 and 50 seeds per meter square for fall rye and winter peas. And in the spring, we used 2 termination methods. One was the conventional termination, we sprayed it out and then disked it in just before seeding on May 18th, and then on May 19th, May 18th and 19th we disked and seeded. And for the other method, we seeded the cash crops, the commodity crops, directly into the standing cover crops. Um, we used Triptyl to seed the commodity crops. The cover crops were spaced at 7.5 inches. So for each plot, we had 8 rows spaced at 7.5 inches. And for the cash crops, we went in between the cover crop rows and seeded it at 15-inch spacing. And we did the seeding on May 19th, and then at that time, the cover crop was about knee high. It was actively growing. And then we sprayed it out on June 8th, was the first in-crop spray. And then on June 22nd was the second spray. For corn and canola, we could use glyphosate because both of these were Roundup ready varieties. And it did a great job at killing fall rye. For dry beans, though, we couldn't use Roundup, so we used Viper and then Viper and Assure. It did not do as great a job of killing a fall rye. It was pretty green even by last week, and still there's some greenish tinge to it. So that's also another thing to keep in mind if you try out this system, to plan how do you plan to kill your cover crop. And I think it's best to stick to Roundup ready varieties, at least when you're starting with this system. But we wanted to have at least one other crop just for comparison purposes. And with dry bean, with its wide spacing, and it's such an important commodity crop under irrigation, it did make sense to have it in this trial. So with that, if you can look at some results, if you go to first page of your handout, we had a decent cover crop establishment in the fall for fall rye, and also a decent overwinter survival. It was about 70% for fall rye. Similarly, for winter peas on the second page, we had a decent establishment. The overwinter survival was lesser. It was close to 50%. And but we did get a decent canopy closure. On third page, the cover crops were covering about 70 to 80% of the surface in the spring, which is pretty good for preventing erosion. When it comes to the main crops, the inter-row cover crops, they did not affect the stand density of the main crop. On page 4, if you look at different treatments on affecting the main crop, there is not a much difference in the mean. So, and there is no statistical difference. So it did not affect emergence. But and we are collecting more data as we are going ahead with the height, biomass, yield. But if you look at the plots visually at this point, it is pretty obvious that the plots with the cover crops, especially corn and canola, they look much shorter. They are pretty behind compared to the direct seeded plots. So, and that is more obvious in the plots that.
Hey, Gurbir, I was going to suggest, this is super visual. Can we move along the treatments and
Yeah,
talk each one?
that'll be awesome. Yeah.
You're overrated.
Was the nitrogen rate changed at all on it?
No.
So that's
I'm gonna go to that. Yeah. So this is living mulch lower density here. So we had it at 2 densities, like I said, and this is cover crop higher density, but it is Des 10, and then this is living mulch higher density. Even with dry beans, you can clearly see that the dry beans are far behind, and that is more obvious when it comes to high density cover crops. Um, I think even with the desk cover crops, they are still behind compared to the direct seeded ones. So this is the control. So in this one, we didn't have any cover crop. We just direct seeded the crops. That's it's kind of the same thing with the other two crops too. Canola. These are the border plots. Again, this one is a plot with we didn't have a cover crop, and just standing here and comparing even with the plot with the lower density, you can see that this one is quite a bit shorter. And this one, just looking at it, I can tell that this is a higher density plot because this is much further behind the other plots. So the differences are quite visual. And I think there are a couple of things that are happening here. I think one of the things was that when we sprayed the cover crop, it was about 2 to 3 weeks after seeding. So the fall rye was quite tall, and so there was probably a shading effect. It tended to shade out the seedlings. So that was one thing. And the other thing was that especially with fall rye, it tends to tie up nitrogen, like Scott just pointed out. And so in this trial, we kept the nitrogen rates same because we wanted to have an apples to apples comparison. We didn't want to provide more nitrogen to the treatment plots, but it is recommended to provide at least 30 to 40 pounds of nitrogen more if there is fall rye cover crop growing before the main crop. So that is something we might need to reconsider moving forward in the next years. And the other thing to reconsider would be the timing of termination of cover crops. It is probably a better idea to terminate them right at seeding. They were about knee high, less than knee high, I would say, and maybe there would be a lesser shading effect. If they are sprayed out at that time, there might also be lesser competition for nitrogen or other moisture too. So that can probably help. We might also look at having more spacing. For this trial, we had 7.5 inch spacing between the cover crops, and we wanted to strip till the middle plots when we seeded. But when we were seeding, we realized that it is difficult to seed on the top of the cover crop rows. So we ended up seeding going in between. So it might be worth having a little bit more space if we want to continue doing that. So these are some of the findings or lessons that we have learned from year one of the trials, and we can see if tweaking them or changing them can make a difference moving forward. One of the good things about this program is that there is a little bit of that adaptive component where we can maybe make some changes and see if those changes maybe make it work better under our conditions.
Here, if I may, you said earlier that you suggest using Roundup Ready canola and corn. So how are you going to control your kochia? Because most of our kochia seems to be glyphosate tolerant or resistant these days. So repeat the question, please. How do you control your kochia in Roundup Ready canola crop?
How do you control kochia in anything these days, George?
Yeah.
Well, Liberty does a great job on it.
I'm hoping that cover crops will probably suppress it.
I mean, because these are the realities that we're facing as agronomists in the fields, right?
Yeah.
So for me to tell my growers to use Roundup Ready as canola in their cover crops, we're going to have a disaster.
Yeah. Yeah. No. There are a lot of considerations that come into because we tend to solve for one problem and then there's something else that we need to consider.
Most of the time the problems all come at once, not one at a time.
Yeah, no, that's true.
Do you think like an early seeding maybe can give a chance to the cover crops to compete with the kochia or other?
Early seeding of cover crops?
Yes.
Yeah, we seeded it around September 20th, and for another trial we had different seeding times for the cover crops. In the spring, we didn't really see much of a difference between between the stages, or there wasn't a huge difference between the cover crops. Yeah. But, so for this trial, we're taking some readings on. We have a moisture probe to look at moisture readings. We're also looking at soil nutrient availability using PRS probes. So, and the standard biomass, height, canopio, and yield readings for both the crops. So we hope to have more data in the fall to be able to answer some of the questions. But for now, I did want to share a couple of results from a farmer survey that was conducted in United States by the Department of Agriculture. It was about 1,200 farmers participated in it. It was a nationwide online survey, but most of the farmers were from northeastern states, so Minnesota, Iowa, Illinois, Ohio, and they have a different growing season there, so their experiences might not translate here, they might not be applicable here, but there were a couple of questions that were on the management side of things that stood out to me and that might be a little bit more generally applicable. So if you go to, I think, page number 5 on your handout, one of the questions was whether the farmers found the overall management difficult with the in-row cover crops. And about 1/3 of the farmers thought that the management was easier, and about half the farmers thought that it was similar compared to earlier termination of cover crops, or if it was more work, the benefits outweighed the challenges. And surprisingly, only about 5% farmers found it not worthwhile to continue doing it. I found it interesting. It is possible that the survey did go to farmers with a more conservation farming bent, but it was still a big sample, nationwide sample, and it was surprising to see only 5% farmers not liking the system. And then the other fear when it comes to cover crops, inter-row cover crops, is that they can harbor pests or disease, or there could be a green bridging where pests could jump from cover crops to the cash crops. And with that, only 5% of the farmers thought that the disease pressure was worse, and 27% saw less disease. About 70% farmers didn't see much of a difference there. For the pests, again, there wasn't much difference. Some farmers did report problems with cutworms though. When it comes to weed control, about 70% of the producers saw benefits with having inter-row cover crops, and only 3% saw more weeds. So weed suppression was definitely one of the benefits that they saw. As far as our experiences with diseases or pests with this trial, we did see less flea beetle damage in canola. There's a picture on the last page of the handout comparing the plots. And there have been some studies that have seen that if there are non-host plants growing, they can disrupt the cycle of the insects, and they do tend to lay less eggs. So overall, I think the main challenges that we have seen is the competition with, and if the competition tends to reduce yield, then it won't be economically viable. So we can hopefully try and do a few things differently to see if we can maybe overcome that aspect. If we are able to, then then there are some benefits to the system. But even if we are not, even then it's still valuable information, I think, to share.
Was there differences in soil moisture? Because you said you had some probes or something in there.
We have some probes. They're taking logging data right now. We haven't looked at the data. It's year one, but yes, like just empirically looking at it, I think there is some moisture difference. Yeah.
I think it's an important point. Like we're kind of going through cover crop mania, even around the world, and it's being seen and touted as the solution to everything. But as this trial here demonstrates, it's not as easy as it sounds. And for the most part, the competitiveness of the cover crops in our environment, especially, yeah, we've got irrigation, but we've had a pretty tough growing season. We have short growing seasons, and the risk of damaging your main crop seems to be higher than the initial benefits. But I think that's the importance of doing this type of work and figuring out, like, we know fall rye is incredibly tough to kill, but it's the only thing that grows actively in our falls to give you any decent amount of cover. So I think this is going to take a lot more work rather than, I'm a little bit concerned at the fact that our governments are now incentivizing cover crops without really providing the background knowledge to do it effectively in each area. So I think that's just something to keep in mind. But you can see right away, especially on the corn, any little bit of competition is dramatically affecting the yield. So we've got this give and take. But if you're dealing with things like glyphosate tolerant weeds, how can we come up with mechanisms that are going to effectively compete inter-row without competing with the crop? So this is going to be a lot of work before there's any hardcore solutions. We also put winter oats in here because it's easier to kill, and it works here. But at the same time, this year none of the winter oats survived. And winter wheat is another option that George has mentioned. Most of the winter wheat across Bow Island, everywhere, died this year too. So we've got these varying years that makes it really tough to come up with any, rules of thumb.
I was just going to make a comment that the only time it really makes sense is if it's either if your soil's going to blow or if you've got a sensitive crop like seed canola.
Yeah. And if we get to points where we get rain on a normal, like if you've got abundance of moisture, that changes the game too, right?
But if you prevent your soil from blowing, well then some stunt in yield, well that's or if you
it's a fair
don't
compromise.
lose your crop and have to reseed, then it's worth it. But it's really interesting seeing this. It's quite a
it's kind of scary, honestly. And we don't know what we're doing, right? Yeah. Like we're just throwing a bunch of treatments together, trying to make it work. And you see on YouTube that this works great in the U.S., but we didn't get our flowering on the crimping until middle of June, and that's way too late, kind of thing. So.
One thing with the nitrogen too, like with the U.S. stuff.
Yeah.
That fall rye, like they don't have to add nitrogen because they're just soaking up all their stuff that they normally lose.
That would be going down the Mississippi.
They're catching it up, and then so that's why they can grow it. Maybe it works more successful, whereas us we have to.
I think we're just.
So are they going in? Are you in the future? You're going to try some tests at lower seeding rates. So for example, all my seed growers on canola, they're way lower seeding rates, right?
Yeah.
And so now our crop competition, we start losing on crop competition at lower seeding rates.
Totally.
That's trouble. Are you going to try a test where you do seed and you seed a cereal at the same time, and then just until that little canola comes up, you get that cereal grow, and then we can spray it out after, or what? Are you going to, because a couple of things too that bother me, and part of this, you said, add 40 pounds. Well, when you're sitting at the price per ton we were this year, at 90 cents a pound, holy crap, that gets to be a lot of money that you're going to add just to kill it out, right? And you don't have a measurement on soil erosion. That's the only measurement there that I got to figure out.
And that was one of the reasons why we wanted to try out without adding that extra nitrogen, but I think these systems, if they work at all under our conditions, they will probably be niche for solving certain problems in certain areas of the field. And even with that too, we'll have to make changes, like maybe terminating them right at seeding and then adding that nitrogen for that, at least that problematic area of the field. So it's not something that we will be able to do all over the farm.
Right. The good news is the seed companies are actually engaged in contract trials with us, trying to come up with some solutions. So it's more on a private basis, but we probably, you know, they're not going to want to share that seed. One seed company is not going to want to share it with the next seed company because that's their competitive advantage. So it's another thing to be careful with as we're moving forward, because there's not the public support that's probably needed to support the high value irrigated sector here. You know, it's just not there.
Do you see much of an allelopathy effect with the rye on the crops that you're seeding into it?
You can, absolutely.
Yeah, it's possible. We have some data on weeds, and we'll see if we do see any difference. We don't have it for now in the year one, so we are going to take the data.
I think the other thing in the U.S. is because they tend to use more row crops with wider rows, you're able to, you know, play a little bit without having to compete with the crop. But most of our stuff is proven to work well on much narrower rows. So in that case, the allelopathic effect in between the rows could be a good thing if you're trying to keep the weeds down. But when it spreads over to hurting the crop, it's not a good thing either. So yeah, the row spacing dynamic with that is challenging as well.
And I thought that with the 2 rows that we had of cover crops between the main rows, again, that cover crop was probably too close to the main crop.
Good. I'm just looking at the boss here. Any quick last questions for Gurbir? All right, well, join me in thanking Gurbir, and we'll load up on the trailer.